So let's continue in 3.1, 3.2, and 3.3. The next property that's really important is the product rule. So here's the what's called the product rule. So for the product rule, this is what it says. Let f and g be differentiable functions. So we won't specify right now, just they're differentiable functions on whatever interval we're talking about. Or all reals or whatever. So then if f and g are differentiable, the product rule says d dx of f of x times g of x is equal to f prime of x times g of x plus f of x times g prime of x. It may be, by the way, that the book has these in different order, but it doesn't matter because you have a commutative property of addition. I like this order better, so whatever function you see here, right off the bat, you can take its derivative. So you do derivative of the first times the second plus the first times the derivative of the second. Okay, that needs to be ingrained in your head, what I just said. Okay, so that's fine. All right. So then, for example, let's do an example first. So for example, suppose I have h of x equal to 4x cubed times the square root of x. Find h prime of x. Now, there's actually a couple ways of doing this. You could actually combine that one, but let's just not for now. So it's like having f as 4x cubed and h as the square root of x, or we could write that as x to the 1/2. Now, I want to make it clear, you could combine those because it's the same base, add those exponents. But let's just do it like this instead. So just for purposes of just showing you, h prime then is derivative of the first, which is 12x squared, times the second, root x, plus the first, which is 4x cubed, times the derivative of the second, which is 1/2 x to the 1/2 minus 1. And then we combine it. Now the rest is algebra. So the rest is algebraic. You just do your algebra stuff. 12x squared, root x, and that'll be plus, and that'll be a 2. So it ends up being 2x cubed over x to the 1/2, because x to the 1/2 minus 1 is negative 1/2. And so you can write that, you can leave it like that, simplify it. There's a lot of things you can do to manipulate this, but let's not get too bogged down in that right now. Okay, so if you wrote this with all radicals, usually when you start with a radical, you want to end with a radical. If you start with a fractional exponent, you can end it with a fractional exponent, but usually want to mimic the same thing. Okay, so what I was going to show you, just notice that you could have done this. You could have 4x, well, I don't need the 4 there. You have x to the third, and then x to the 1/2. You could rewrite that and just get x to the 7/2. And so if you left it as that, then you don't need the product rule. So sometimes often doing a little algebra first saves a little trouble, because, it's not too bad, but this is kind of messy, but you take some algebra to clean it up. You could do root x over root x, simplify things, etc. Okay, so next we're going to look at the proof for that. This is the proof of the product rule. Okay, so proof of the product rule. Assume f and g are differentiable. Right? I mean, that's the assumption. That's the product rule right there. So we have to say f and g are differentiable, and then you're going to show this step. So now we're going to basically take the limit of that product and then see what happens. Okay, so what we're going to do, what I'm going to say now, I'm going to say this. I want to let capital F of x, this is just for notation purposes, equal f of x times g of x, like that. Just to kind of show you what happens. So f prime of x, then by definition, is the limit of capital F of x plus h, I'll use h this time, minus capital F of x all over h, as h approaches what? 0, yes. So that then is equal to the limit of f of x plus h times g of x plus h minus f of x g of x all over h as h approaches 0. Now this is now you got to expand that out. So that's equal to this. Oh, no, what I'm going to do is basically add and subtract the same thing. So check this out. This would not be obvious, really, but I can add 0, right? I can always come in here and say like plus 0, but I can say a minus a or b minus b, and that's always equal to 0. So watch this. I'll highlight it and show you, but what you get then, this is the key to the step. It's the limit as h approaches 0. It literally is that entire line. So you do f x plus h, g of x plus h, minus f of x plus h, g of x, plus f of x plus h, g of x. Okay, so there's my plus minus right there. Right, those are opposites. And then minus f of x, g of x all over h. So these right here, these are my opposites right there. One's plus, one's minus. And you can see that you would, of course, get two different things. Okay, so those are opposites. And so that adds to 0. Okay, so I just added 0 right there. So that allows me to, now I break it up and manipulate it like this. So now what I'm going to do is basically rearrange it and factor out values that to help me simplify it to what I want. Because what I want is this. I need this form. I want f prime and then f g prime. So let's see if that is what I get, or vice versa. You could write that a different order. So this is equal to the limit and then f of x plus h as h approaches 0 times the limit g of x plus h minus g of x all over h as h approaches 0 plus the limit of g of x as h approaches 0 times the limit of f of x plus h minus f of x all over h as h approaches 0. And you can, okay, so how did I do that? Well, I came up here, I broke up that, I put x plus h with my g, where'd it go? I rearranged it. So factoring out your g of x here, and you're left with the f of x plus minus f of x. Okay, and then back here, factor out the f of x plus h goes in front here. I'm left then with the g x plus h and g of x, which is this. Okay, you need to study that a little bit. You want to have your mind grasp what we just did. Make sure you're writing it all out too. So that's basically it. I mean, basically, that means what we get then is this above is f of x. If you have inside the function h going to 0, this is, oops, wrong button. This is going to 0. And then there's no h here, so that's just g of x. And these are the derivatives. This is g prime, and this is f prime. And then we just commute it to get the above one that I like. So it's f of x, g prime of x, plus g of x, f prime of x. And you can just rewrite that or commute that and get f prime of x, g of x, plus f of x, g prime of x. That's just by the commutative property of addition and multiplication. Okay. Next thing is the quotient rule. So the quotient rule is, I'm not going to go through that proof. This says let f of x and g of x be differentiable. And g of x, the denominator, non-zero. So this one says if you have d dx of the quotient of f of x and g of x, like that, that's equal to f prime of x, g of x, minus f of x, g prime of x, all over the denominator, g of x squared. Okay, so let's look at an example of the one above. Okay, this is number 20, page 121. Suppose f of t is equal to t squared minus 1 over t squared plus t minus 2. Can't really simplify that one. You can't really divide and get something nicer. So this is just a product rule or quotient rule situation. So what you get then, f prime of t is equal to, so you do the derivative of the top, which is 2t, times the bottom, which is t squared minus t minus 2, minus the top, which is t squared minus 1, times the derivative of the bottom. So the derivative of the bottom one is what? 2t plus 1. And then it's all over the denominator squared. T squared plus t minus 2 raised to the second. Okay, so that's the derivative. We're not going to simplify now, but you can, and our goal will be later to simplify stuff. You distribute, and simplify. So there's more examples to that. So I would do more, you need to practice these. We'll do more in the problem sessions, practicing just derivatives for sure. If not, probably not Tuesday or, first early in the week whenever you're viewing this. But we'll need to look at those. But we really just did 3.1, 3.2, and 3.3. So we just did all that. There's more to do in there, but we will kind of do stuff as we go, answer questions. We will go on to 3.4 on the next videos.